Okay, so for number 14, we have that A and B are two pairwise disjoint family of sets. So let's just briefly recall here the definition of pairwise disjoint. So we have that set 1 and set 2, are pairwise disjoint if S1 is equal to S2 or S1 intersection with S2 is empty. So we're saying, hey, for any two sets, the only way for their intersection to not be empty is if these two sets are the same set, right? So this definition pretty much guarantees that no two sets are going to have anything in common. All right, so for item A, we want to show that the family C, which C is the intersection of the family A with the family B, is a family of pairwise disjoint sets. So we're going to say let C1 and C2 belong to the family C, right? So then C1, maybe I should say, note that the family C is the intersection of the family A with the family B. So if C is the intersection and C1 and C2 belong to the family C, thus C1 and C2 belong to the family A, and C1 and C2 belong to the family, B. So because it belongs to the intersection of A with B, C1 and C2 have to belong to A, and C1 and C2 have to belong to B. As A and B and script B are families of pairwise disjoint set, pairwise disjoint sets, it must be the case that C1 is equal to C2 or C1 intersection with C2 is empty. Because since C1 and C2 are both in A and B, they have to be pairwise disjoint, or else they would not be in A and B, since A and B are pairwise disjoint. And so since we've taken any two generic sets from the family, and we've shown that, hey, these sets here are pairwise disjoint, therefore the conclusion is going to be, therefore C is a family of pairwise disjoint sets. So that is it for item A. We took two sets from the intersection and then showed that they must be pairwise disjoint. So C is a family of pairwise disjoint sets. So now for item B, we're dealing with the family D, which is the union of the family A and the family B. So we want to give an example, which is a counterexample to the claim that D is also pairwise disjoint, right? So we need to show that D need not be pairwise disjoint. So what we're going to do here is we're going to say, let A be the family containing the set 1 and the set 2. You can see that these families are pairwise that A is pairwise disjoint, right? Because none of these sets have anything in common. And B is the family containing the set, 1, 2, and the set 3. So you can see here that both A and B are pairwise disjoint. So, which means then that the family D is going to, since D is the union of A with B, D is going to, we're going to join these two families. So it's going to have the set 1, the set containing 2, the set containing 1, 2, and the set containing 3. So that is D, the union of it. And we can see that the set 1, 2 belongs to D, and the set 1 belongs to D, and the intersection of the set 1, 2, 1, 2 intersection with the set 1 is not empty because the intersection contains the element 1, which is common, right? We could also have done the set 1, 2 with the set containing 2. So right here we've produced an example where we have these two families, A and B, so you can see that this has nothing in common, and similarly these have nothing in common. However, when we join them into a single set, which is the union of it, this family here is not necessarily going to be pairwise disjoint because these two sets are not pairwise disjoint. Similarly, this set with that one is not pairwise disjoint, right? So that is a counterexample. And now so for C, we're saying that if the union of the family of A and the union of the family of B are disjoint, that is, their intersection is empty, then the family D, which is the union of A with B, is pairwise disjoint. So we're going to say, for C, we're going to say let the union of A belonging to the family intersection with the union of B belonging to this family, let it be disjoint, right? Which means that their intersection is empty. And we're going to say, and let the family D be A union B for pairwise disjoint families. A and B. Right? Let me make this script here. Okay, so we are assuming that the union of these two families is disjoint and that D is A union B. Okay, so now we're going to say we're going to take two elements that are in the family, and we're going to show that for these two elements, either D1 is equal to D2, or D1 intersection with D2 is empty, right? Because we're trying to fulfill the definition here for pairwise disjoint. So we're going to say let D1 and D2 be elements of the family D. Since the family D is the union of A with B, then what it means is that D1 belongs to A or B, or family B, and D2 belongs to the family A or the family D, right? Because since the family D contains the unions, then if we take any two sets, these two sets either came from A or they came from B. So now we're going to do it by cases, right? We're going to consider two cases here. So case one, what we're going to do here is we're going to consider without loss of generality, so we don't have to repeat it. So we're going to say D1 and D2 belong to B, or D1 and D2 belong to A. So the first case is where these two sets come from the same family. They could either both come from B or they could both come from A. So as A and B are pairwise disjoint families, D1 and D2 must be pairwise disjoint. be pairwise disjoint. So that's the first case, right, where both of them either come from A or both of them come from B. And case 2, we're going to say D1 belongs to A and D2 belongs to B without loss of generality. Without loss of generality. And this without loss of generality means that the arguing that we're going to do here is also valid for the case where D2 belongs to A and D1 belongs to B, right? Because D1 and D2 are just, they are any set. So it doesn't matter if we let D1 belong to A and D2 belong to B or vice versa. The only important thing is that the two sets come from two different families. It doesn't matter which is which. So that's why we use this without loss of generality, so that we avoid using the same argument for the other case. So if D1 belongs to A and D2 belongs to B, what we're going to do here, we're going to say we have that as, so maybe I'm going to say as the union of A belonging to the family A intersection with the union of B, so B belonging to the family, is empty, right? What does this mean? For all A belonging to the family and B belonging to the family of B, let me put that in script, and B belonging to the family of B, what it means here is that A intersection B is empty, right? So we're saying, hey, since the union of A intersection the union of B is empty, it means that any two sets that you take from A and from B, their intersections are going to be empty. Because if there existed two sets, one from A and from B, where their intersection was not empty, it would mean that the union, which contains those same elements, would not be empty, right? The intersection of the union, sorry. So for any set that you take from here and from there, they're going to have nothing in common. Thus, what it means is that D1 and thus D1 intersection with D2 is empty, so D1 and D2 are pairwise disjoint. So what we've done here is we've shown the two cases that we could have where either the two sets come from A or the two sets come from B. That means that they are pairwise disjoint. And the second case is where D1 comes from A and D2 comes from B, or vice versa. And because the intersection of the unions is empty, it means that for every single set from A and from B, their intersection is also going to be empty. Thus, D1 and D2 are pairwise disjoint. So since we've shown that in either case, D1 and D2 are pairwise disjoint, so our conclusion is going to be, therefore, what we're trying to show is that D is pairwise disjoint, the family. Therefore, the family D is pairwise disjoint. Let me fix this here, disjoint. So yeah, that is it for item C. We took two sets from the union, and we showed that in either case, these two sets, D1 and D2, are pairwise disjoint. So it means that the family itself is pairwise disjoint.